So now it's time to go back and review everything that's been in this unit about circles, equations of circles, and volume. So way back in the beginning, we started with circle equations, and if you remember, our basic form is x minus h squared plus y minus k squared equals r squared, where our center is at the point hk, opposite signs, and our radius is the r. So you remember you have to take the square root of whatever it said equal to find your radius. So for this one, the center is going to be a positive 3, negative 1, and then my radius, the square root of 25, would be 5. So to graph it, I would go on my graph to 3, negative 1, and then I can't count diagonally, so I'm going to go up 5, down 5, left 5, and right 5. And there's a very awkward looking circle. Okay, then I want to write the equation, so to do the opposite, get it back into that equation form, given that the radius is 12 and the center is at 3, 0. So the h is always first, it goes with the x, so I'm going to have x minus 3 squared plus, and because k is 0, I'm just going to have y squared, equals, and then 12 squared is 144. Alright, then the second one, I'm going to have x plus 1, because it's opposite sign, squared, y minus 2 squared, and then the square root of 13 squared cancels out the square root, so I have just 13. And we also looked at finding the standard form of circles given it when it's all multiplied out. So we have to do that by completing the square. So to begin with, I need to make sure my x squared and y squared have a coefficient of 1, and they don't, so I'm going to divide everything by 2. And that's going to give me x squared plus y squared minus 2x plus 2y minus 2 equals 0. And then I'm going to add 2, and at the same time get my x's together and my y's together and add the boxes. So I'm going to have x squared plus minus 2x plus the box plus y squared plus 2y plus the box equals 2 plus 2 boxes. And squeeze that box in. So to figure out what goes in the box, we take b, half of b, and square it. So half of b is negative 1, squared to positive 1. Half of b is 1, squared is 1. And then this side I'm going to write in my parentheses. To figure out what goes in the parentheses, we just take half of b, so a minus 1. And then over here a plus 1. And then 2 plus 1 plus 1 gives me 4. If I wanted to go ahead and graph this one, my center would be at 1, negative 1. And my radius would be 2 because I need to square root whatever it's equal to get the radius. Then we looked at volume. So we had 5 different volume formulas we looked at. The first one's a prism. So that's this first shape up here. So the volume of a prism is the area of the base times the height. For this example, if I chose this front one as my base, to find the area, it's a rectangle. So I'm going to do 2 times my height, which is 1, because it's the same as back here. So 2 times 1. Then take that area times my height of the prism, which is 3. So 2 times 1 times 3 is 6. This one's a pyramid, so the volume of a pyramid is 1/3 times the area of the base times the height. So in this case, my base, again, is a rectangle. So to find the area of a rectangle, we do length times width, or 10 times 8. And then the height, with the right angle, is 6. So times it by 6. Alright, so if I do 1/3 times 10 times 8 times 6, I end up with 160. Alright, the next one is a cone. So my cone, the volume formula is 1/3 times pi r squared h. So I've got 1/3 times pi. My r is 3 squared times my height, 11. And then that's going to end up giving me 33 pi. And we just leave the pi in there. A cylinder is just pi r squared h, same as a cone but without the fraction. So for this one, I've got pi times 3 squared times 5. And then 3 squared is 9 times 5 is 45. So we get 45 pi. And then the last one is our sphere, and that one's got the weird formula 4/3 pi r cubed. So we have 4/3 times pi. Now in this case, my diameter is 18, which means my radius is 9. So when we do 9 cubed times 4/3, we end up with 972 pi. Okay, the other types of volume problems we did involve putting more than one of these shapes together. So if it's on the outside of each other, you add. If they're inside each other, we subtract. All right, cross sections are what happens if you imagine slicing your 3D shape, and then whatever 2D shape is formed, that's your cross section. All right, so just remember, parallel to the base, no matter what shape, it's going to be the same shape as the base. And then if it's perpendicular and through the a prism, it's going to be a rectangle. And if it's perpendicular through a pyramid and goes through the point, it's going to be a triangle. And if it's not the point, it's going to be a trapezoid. Other than that, you just have to kind of visualize and maybe draw. So for the first one, we've got a triangular pyramid. Right, so that means my base is a triangle. So I got a triangle base. All right, so here's my pyramid. And the first one is parallel to the base. Well, no matter what, parallel to the base is the same shape as the base. So in this case, it's a triangle. Perpendicular to the base and through the top vertex, that's this up here. So anytime it's through that and perpendicular to the base of a pyramid, it's going to be a triangle. And then not through the top vertex, but parallel, it's going to leave us with a trapezoid. Because that ends up being something kind of like here, which I know that's kind of hard to see. But if this was a slice, it would end up being a trapezoid. And then we rotated 2D shapes to form 3D shapes, to which we then find the volume for. So just a quick reminder, if it's a rectangle or a square that we're rotating, it's going to be either a cylinder or a cylinder with a hole in it, like a toilet paper roll. And then if we take a triangle and rotate, it's going to either be a cone or a cylinder with a cone hole. And then a semicircle is always going to give you a sphere. So for this one, I want to rotate this rectangle around the y-axis and find the volume. So here's my y-axis. So the first thing I'll do is reflect it over. So there's my reflection. And then if I draw my circles, I'm going to end up with a cylinder with a cylinder hole in the middle. So I'm going to get a toilet paper roll. Alright, so here's my two cylinders. The part that I need, one of them I need the radius, I need the big radius, and then I need the little one radius. So the big radius looks like it goes from 0 to 4, so that's 4. And my little radius is just 0 to 1, or 0 to negative 1, so it's 1. And the height of both is 2. So like in words, to find the volume of this, I'm going to take the big cylinder and subtract the little cylinder. To find the volume of a cylinder, it's pi r squared h. My big radius is 4, and the height is 2. And the little radius is 1, and the height is 2. So 4 squared is 16 times 2 is 32. And 1 squared is 1 times 2 is 2. And because they both have pi, I can combine them. So 32 minus 2 is 30. So my volume is 30 pi. And that's everything we've looked at from this unit.